This is Robert Leduc, and today I'm going to review challenge activity 4.18.1, Circuits to FSMs. And this challenge activity is broken up into two parts. And the first part, they're going to give us a circuit here and a partially filled out truth table. In which we're going to have to fill in some missing values. So to kind of help you follow along, I've just made a snip of the circuit over here so I can make some notes. And the first one they ask us for is this value P, which corresponds to N1. So referring to the copy of the circuit over here, it's looking for P, which is our value, N1. So that's what we're looking for. And that corresponds to the following values coming out of the state register. P1 is 0, and P0 is 1. And our value of our input B is 1. So now that we know the inputs going into these logic gates, we should be able to figure out these missing values. So for P, we have an OR gate, and it's a 3-input OR gate. And for the value coming out of the state register at P1, it comes in unchanged, and it is going to be 0. For the value coming in from P0, it's also coming in unchanged. Whoops, it's actually not 0. That's coming in as a 1. And because this is an OR gate, I already know what the value of N1 is going to be. I know it's going to be 1. It only takes one of these inputs to be 1 for the output to be 1. But just to finish the analysis, we do have input B, which is inverted, which would be a 0. But that doesn't matter. We have our 1 input over here from P0. So we know that the value of N1 in this case is going to be 1. So I'm going to go ahead and fill that out here. Oops, guess I have to start that first. All right. And then, actually I won't clear that. Let's just move on to N0. So N0, which is this Q value that we're trying to find the value of, N0 corresponds to these two logic gates, this OR and this AND, with a single invert on one of the inputs. So we'll go ahead and evaluate this. Now this one is kind of straightforward because we could see immediately that B, input B, is going to be 1 at this AND gate. So we already know right off the bat this is going to be 1. But let's go ahead and finish the analysis. So here P1 has a value of 0, which means we already know this AND gate is going to have a value of 0. And the other input is inverted, so that's going to be a 0. But that's okay. We know this is going to have a value of 1 because the input straight to the OR is 1. So now we know our value of Q is 1. It also asks us for the value of R here, which corresponds to output Z. So Z is right here, and this one should be pretty straightforward because Z only corresponds to one of these values, and it's this P1 value here coming out of the state register. We know in this state we have a value of 0 at P1. So we know that Z must also have a value of 0. And that was R. And then lastly, we'll find the value of S, and that down here, and just so it's less confusing, I'll reset that. So here, we're only concerned with one of these values. So again, Z is connected directly to the output of the state register value P1. So we know that this value in this case is going to be 1. So we know that the value of Z is going to be 1. So that was pretty easy. All right, and then we will check our answers, and says we got the right answer. So that's pretty good. So that wasn't too bad. We'll go to the next part, and the next part's a little bit different. They give us a completed truth table, and it's partially converted into an FSM here, and they're asking us to sort of fill in this missing information here. So what I'll do is I'll make a new snip, and I will just grab this truth table so I can kind of help you follow along a little bit better here. So the first thing I'm going to do with this is I'm just going to draw a partition down the middle between my inputs and outputs, and I'm going to divide this into states, just to help us stay organized and make sure we're looking at the right rows and columns. Okay, and right here, the state where the register state values are 0, 0, that's going to be E. The next one down, 0, 1, is going to be F. And the corresponding values, just so you know, are over here in these blue circles, which represent the states. So 0, 0, 0, 1, there's 1, 0 is G, and then H is 1, 1. All right, so now that we're a little bit more organized on the truth table, it's asking us, what is the transition condition P? So let's see, let's find P. Okay, so it's this one here, going from state G to state H. So state G is right here, which corresponds to the state register values 1 and 0. And between G and H, there's only one transition arrow here. So that tells me that we're only, oh, you know what? I'm sorry. There's actually another transition arrow going back to F. So there are actually two ways this could go. And that makes sense because if you look over here, we have, you know what? I'm going to erase that. I'll do another color. So we have values of N1 and N0, of 0, 1, and 1, 1, depending on the input, right? So in the case that the input B is 1, I'll grab another color here. In the case that the input value is 1, the state register values correspond to the values at H. So for input, or yes, for input 1, we're going to transition to H. So that is our answer for Q, or I'm sorry, for P rather. So we'll just put H right there because they're asking, oh, I'm sorry, it's not H. They're not asking for the state. I'm sorry, they're asking for the transition condition, which would be B. So that is where B is 1. Sorry about that. And then the next one asks for the transition condition of Q, which is the other possible transition that can be made from state G. And for that, it's 0, 1, and 0, 1 corresponds to F right here. So in the case that the input B is 0, state G will transition to state F. Right? And that is for input B 0 or B prime. Okay? And then it asks us what the next state is, R. So that's this state after H that H is pointing to. So we already highlighted where H is here. That's the state represented by state register values 1 and 1. The next state is going to be right here. We actually only have one option for a transition from H, and that is to values 1 and 1 for N1 and N0, which corresponds to the original values of H. So H is just transitioning back to itself. So it's just cycling back to itself, and that's for either value of B. That's for either input. So no matter what happens, no matter whether B is a 1 or a 0, H is just going to constantly transition back to itself, cycle back to itself. So the next state of R here is H. All right, so what is the value of M? Okay, so the last two are referring to Z, which is the output of these states. So these should be pretty straightforward, hopefully. So in the case of M here, we're referring to state G. And these are the two outputs. The outputs that correspond to either input condition. So in both cases, the value of the output is 1 for state G. So the answer is 1. And for the last one, it asks us for the value of N, which corresponds to state H, which would be these values right here. And in both cases, regardless of whether the input is 0 or 1, the value of output Z is going to be 0. And that's our answer for that one. And now we should be able to go ahead and check our answers. And all right, looks like we got everything right there. So hopefully that helped. This one was a little tricky for me at first, just to kind of understand what it was asking for. But if you do this a couple times, you should find it to be pretty straightforward. So thank you for watching.